Hi, so in this video, we're going to talk about FHRP, First Hop Redundancy Protocol. So I do have a lab that goes along with this, okay, that you can get from my GitHub repository, or students in my class get that in class. But so we're going to be looking at configuring hot standby routing protocol. So basically what happens when the default gateway, let's say this is our router, our default gateway, our layer 3 switch for devices on these networks. This is our default gateway for devices on these networks here. What happens if this default gateway goes down, this layer 3 switch? It's a single point of failure. So we can make it so this device here, this layer 3 switch, is a backup standby default gateway for these networks, and this device here would be the default gateway backup for devices on this network. We can do that, and I will probably do that in a later lab, but it's a lot of connections and a lot of different SVIs. So I'm going to use this network up here as an example. It's much more straightforward, much simpler. This is our 10210 network. Let me zoom in a little bit on that. Here we go, 10210 network. Right now, this device here, DC1 layer 3 switch, is the default gateway, as we'll see in a moment. So we're going to be using the PC0 down here to communicate, and that should be 1010, shouldn't it? Let me change that. There we go. 1010 1.0. 1.0. There we go. Always these typos somewhere. I try and correct these as much as I can. All right. Sorry about that. But we're going to see how this device here will use the DHCP DNS server when it's communicating with, let's say, PC0 down here, how it goes through this default gateway, but what happens when its default gateway fails. So that's what we're going to be doing here. All right, let me go ahead and zoom in here. And the way we're going to start this lab, though, is to do a little work here. On the previous labs, one of them we did spanning tree, rapid spanning tree, port fast. We're going to do the same thing up here. So while we're here, so bear with me for a moment, but we're going to configure rapid spanning tree on this switch and also port fast. So let me go ahead and do that. I'm on DC. Access DC right there. I'm just going to do config T and spanning tree. And then I'm just going to do rapid PVST. Whoops. Rapid mode. There we go. Love it when I make mistakes, because see that there? It means I didn't understand what this is. And if we're never sure what the problem was, do a question mark. Mode is what I need next. Okay, and then I can see, oh yes, rapid spanning tree with rapid per VLAN spanning tree. That's what Cisco uses. Okay, next what we're going to do is just configure port fast on actually all these ports. You can see that's reconverging here real quick. But let's go ahead and we're going to do port fast and BPDU guard on all of our end devices. And that can also, by the way, that can include our router ports, as long as there's not another switch there. Well, let me explain that in a moment here. Let's do interface range, FA0/13. So that's these three here. And then we'll also do FA010. That's this one here. Okay. So I'm going to do spanning tree up. There we go. Now we'll take the do the let's see, auto config there. So let's do port fast. Autocomplete is the word I was looking for. Okay, so it's warning me that only a end device should be it says a host, but a host here, router really is a host, another computer. But what it's saying is don't connect another switch to these ports because it's going to create problems. Okay, to these ports. And like, not a problem. We're going to do also, just in case somebody does that, we're going to do BPDU guard enable. And also going to do the same thing on these two ports. Let's do interface range, gigabit 0, 1 to 2. Okay, up arrow here. Port fast, which is fine because as long as we don't have a switch there. And we want, when those devices, those layer 3 switches connect, we want them to go ahead and start forwarding right away on those ports. Let's do BPDU guard as well. There we go. All right. Now we can get started on first hop redundancy protocol, FHRP. Get rid of. We're going to come back to that switch later to look at some other things. All right. So let's go ahead and look at PC0. Okay, so I'm looking at PC0 right here, and it has this IP address, so I need to remember that, 10.10.1.151. Great. And we see that it's default gateway. That's fine. Let's see. Yep, that's going to be here. But this is the device that we're going to be pinging. Okay, so let me get rid of that momentarily. Let's go up here. Let's take a look at our DHCP server that we're going to be using. IP config. And we can see this, that's its IP address, subnet mask, but this is what we want to see. 10.2.1.1. This is its default gateway. All right. All right. And first of all, let's make sure we can ping our PC0, 10.1.150. And I'm going to, let's just make sure we can ping it. Oh, wait a minute. 151, wasn't it? There's probably a 150 out there. There we go. This is the one I wanted. Okay. An ARP request had to happen somewhere, maybe between here and the default gateway. All right, so let's do this. I'm going to continue this ping for a while. I'm going to do dash and let's do 50. Okay. And while that is going, I'm actually going to shut down this port right here. So we're going to see that those pings eventually will fail when I shut down that port. Okay, let's do config T interface gigabit 101 right here. Okay, I'm going to do a shutdown. And as soon as I do that, okay, we should see that. There we go. Now it's failing. Let's do one more. There we go. All right. Now, the reason why it failed, I think we can see why, is because, well, I do an IP config here. This is the default gateway, right? Well, so what are my options here when this fails? Without, we're going to see the best option, first hop redundancy protocol, but manually what I can do is I can change, well, how do I make this device the default gateway? I'd have to go over here and change this to a .1. That's one option. Excuse me. Another option would be to change the default gateway on this device to be the .2. Well, if all my devices are getting, let's say, getting their information from a DHCP server, and I wanted to change the default gateway to be .2, I would have to change the default gateway on the DHCP server and then have all the devices renew their IP addressing information to get the new default gateway address. That's a bit of a pain. So that would be one that would be another possibility. All right, But really, that any of this, whether it's changing the IP address of this device to be .1 or to leave it at .2 and change these statically and on the DHCP server, either way, it requires manual intervention and doesn't happen quickly or quick enough in many circumstances. So what we're going to do is, first of all, let me go ahead and do a no shutdown on this interface. Excuse me. A little early morning. There we go. Did you notice that came green right away? That was because of rapid spanning tree. All right, so let's go ahead and get started on configuring HSRP, Hot Standby Routing Protocol, which is a first hop redundancy protocol. First thing I'm going to do is we're going to be creating a virtual router. We'll talk more about that in a moment. But what I'm going to do is I'm going to change the IP address of this one here to be .3. Because we're going to leave the default gateway as 10.2.1.1 for all of our devices. We don't have to change them statically or the DHCP server or any of that. So I'm going to change the IP address here to be .3 because we're going to see here in a moment that the virtual IP address for FHRP is going to be the .1. So let me go here first and let me make sure, excuse me, make sure I'm on the gig 101, make that clear. You don't have to do the no IP address command, but I like to. Not required on IPv4, as IPv4 can only have one IPv4 address, but IPv6 can have several IPv6 addresses. Okay, sorry about the frog in my throat for this lab. I got allergies this morning, I guess. Okay, IP address 10.2.1.3 is what we're changing it to. 255.255.255.0. Does that look all right? Yes. All right. If I do show IP interface brief, I should see the new address. Yes, right there. Looking good. All right. Obviously, our device cannot ping PC0. Okay, because although it has a default gateway, this default gateway does not exist. I love this. What just happened? But Rick, I thought you said this does not exist. Let's do this. ARP-A. Okay. Although it does not exist, it still thinks, hey, I do have a default gateway. And in my MAC address table, I have the MAC address from a previous ARP request when I was able, when this was my default gateway. Okay. Love this stuff. So it's just that it still had the MAC address cached for its default gateway. All right, so let's do this. ARP-D, let's get rid of that. Let's do ARP-A, no ARP entries found. Now, when it does an ARP request, hey, who out there's 10.2.1.1? Give me your MAC address. Let's see what happens. Do the up arrow here. Hey, nobody's responding because this IP address is not out there. It's not on here anymore. So we're getting request timed out. Great stuff. Love this stuff. All right. Now we're going to configure. There we go. There we break out of that. We're going to configure hot standby routing protocol. So let's do that. So what we're going to do is configure both these two layer 3 switches to be participants in HSRP. So let me go here first, DC1. And I'm going to go to interface gigabit 101. Standby is the standby command means HSRP in the IP in Cisco world. I'm going to do 1. This is the group number. So for load balancing, we can have different groups, but these two devices here, these two routers, going to be members of the same group. Okay, IP, and this is where I give that's where I give the default gateway address that these devices are going to be using. This is what's known as the virtual IP address. Okay. And so this we're going to see here in a moment. Going to do this next command, standby 1. That's the group number, priority 200. The default priority for HSRP is 100. A higher priority means this router is going to try and be what's called the active default gateway. Whoever has the highest priority will be the active default gateway. Standby 1 preempt. What this command does, we just saw it. See, it just became HSRP state change. So first it said, I'm standby. Let me see if anybody has a higher priority than me. Looks like nobody does. I'm the only one in my group right now. So I will go from standby. I'll be the active. Preempt command. If Rick can spell preempt, which he can't. There we go. What preempt does is says, if for some reason I'm no longer the active default gateway. Let's say I go down and I come back up. We'll be doing this later in this lab. I will preempt. I will try and take over if I have the higher priority. Okay, so that's easy enough. And you know what? It's the exact same commands, slightly, almost the same on DC2. Just we're going to give it a different priority. Interface gigabit 101. Okay. We're going to do standby, same group number 1, IP, same virtual IP address. So they're both saying, yeah, I'll be the default gateway for 10.2.1.1. But standby 1 priority. There we go. I'm going to use the default. I don't have to put that 100 there, but I like to do it. This is the default priority. So it's just saying that I will be that's my priority. If somebody has a higher priority, they'll be the active. If there's nobody else, or if I have the second highest priority, then I'll be the standby, which I am. Okay, standby 1 preempt. Same thing. If another router, let's say another router is involved and actually becomes the standby, then I will, then if I enter and I actually have even a higher priority, let's say I change this, or it has a lower priority than me, I'll take over as the standby. All right. Let's see this in action. Okay, so one of the things I want to show you here is this is good stuff here. The show standby command, I just want to show you this. This is the virtual, they both will show this as the virtual IP address, and there's a MAC address associated with it. This first part here is the organizational unique identifier, Cisco. This part here says this is HSRP, and this is actually the group number. If I do it here as well, show standby, you're going to see the same information. Okay, virtual IP address, same one, same MAC address. Why am I showing you this? Okay, well, we're going to see here in a moment that when this device tries to reach, does a trace route and to reach PC0, we're going to take a look at what MAC address is being used. So let's do that. Okay. So first of all, let's do a ping. Let's make sure we can ping it. Now our pings work, right? All right, let's do it. Again, whoops, if I can spell IP config. There's our default gateway. Okay, what's our ARP table show? Look at this. See that there? That MAC address? That's the MAC address, the virtual MAC address of our virtual IP address. Okay. Very cool. But here, this is also very cool. Well, let's do the trace route, and then we'll take a look at the MAC address table. Trace RT 10.10.1.151. Now, why is it saying 10.2.1.3? Talk about that in a moment. Okay, but let's look at the MAC address table on that switch. Okay, notice the MAC address table for gig 01, okay, is actually, that's the IP address of the virtual MAC address on that port that's associated with the virtual IP address over here. Okay, so when Ethernet frames are sent, when this device says, "Hey, who out there's 10.2.1.1," this device says, sent the ARP request. This device sent the ARP reply, but when it sent the ARP reply, it used its virtual MAC address, not its own MAC address. Okay, so that's why we're seeing that virtual MAC address that we see right here. Okay, the other thing I wanted to point out here is, why is this 10.2.1.3? Don't worry about this request timeout. It's a packet tracer thing with OSPF. But anyway, 10.2.1.3, that's because what's being sent back is an ICMP time exceeded message. When this device here, DC1, dropped the ICMP echo request with a time to live of 1, it sent back an ICMP time exceeded message, but sent it back from its physical interface, this interface right here. So that's why you see this on a trace route. All right, all good stuff, all really good stuff. Okay, next we're going to do is, well, what happens when we shut down this interface? We have an active HSRP router right here, and then we have a standby here. So what we're going to do here is we're going to do that ping again. Ping 10.10.1.151. Okay. And I'm going to do a -N50 in just a moment. Okay, but what we're going to do here, interface gigabit 101, we're going to get ready to shut down this interface in the middle. I'm not going to do it yet. Get it all set. We're going to shut down this interface. This is the active router. Okay, so we're going to see what happens when we shut down this interface. Before, remember, without an FHRP protocol like HSRP, they failed. Let's see what happens. Okay, so let's go ahead and start this ping. It's all working, great. Let's shut down that interface. I'm showing you DC2 here for a reason. Well, let's see let's make sure we got that. You can see that happening. Let's see what's happening. Oh, look, just went from standby to active. And look, our pings continued. See all that? So what happened, let me move that around here. The pings were failing. Then after 10 seconds, that's the hold time, the default hold time. It says, hey, I haven't received a hello, HSRP hello from you in 10 seconds. You're supposed to send them to me every 3 seconds. So I'm taking over as active. Okay. Now, the other cool thing I want to mention here is great, but what happened? Remember those Ethernet frames? We're going to, this device here. I'm going to close this here. Okay. Remember, it's ARP table. This device says, Yes, I'm still sending anything to default gateway. Those packets are encapsulated in an Ethernet frame with this as the destination MAC address. The switch was forwarding. Remember, we saw the MAC address table here? You were forwarding those out gig 01. How come those aren't being forwarded still? This is down. So what's happening now? Let's take a look. Notice here that MAC address table is now associated with gig 02. How did that happen? Well, what happened is when this device became the active router, it sent out a gratuitous ARP request, basically just saying, hey, who has 10211, which is me, send me your MAC address. Basically, it was just sending an Ethernet frame from the MAC address. Let me bring this up here. It was just sending a MAC Ethernet frame from this MAC address. That way, this switch would learn that this MAC address is now on this port. So those frames now going to the default gateway, packaged to another IP address, but encapsulated with this as the destination MAC address, right? Destination MAC address. They were now being forwarded out gigabit 02. Okay, pretty cool. All right, so let's do another trace route. Can I just do an up arrow here? Yes. Notice that now verifying that the time exceeded message is actually coming from 10 to 1.2, this interface here. Love this stuff. All right, let's go ahead and I'm going to do a no shutdown on this interface here. And we're going to see that because we have preempt and enabled, that it's going to take over as the active router. So let's do a no shutdown. Okay. And we can see state change from standby to act, went from, well, we go up here at this, there's several states HSRP goes through active. So it went through several states, but it eventually became active. And we come down here, we can see, oh, now you've taken over. I'm back at being standby. And again, let's just do that trace route one more time. Okay, and now here's the beauty. We don't have to do anything here. Okay, I'm going to do that trace route one more time. Come on back, Tricia, you can do this. There we go. 10213. Yep, that's where they're going through now. Pretty cool stuff. Okay, we've already taken a look at a couple of commands, but let's look at them again to verify HSRP. Okay. Show standby. Let's do that on both of these so we can compare. I'll do it again on this one here. All right, so we can see that this one here is active. This one here is standby. No, that's not going to work. There we go. Okay. They both have the same virtual IP address and both have the same virtual MAC address. Okay. Hellos, HSRP hellos are sent by default every 3 seconds. That's configurable. And 10 seconds is the whole time, meaning it's standby, doesn't hear from the active in 10 seconds, it takes over. They both have preempt enabled. It tells you who the active router is. Here it says, I'm the active router. Here it says that IP address is the active router, and it has a priority of 200. Who's the standby router? This IP address is standby router. They have a priority of 100. It says here, I'm the standby router. Okay. And another command we can use to look at this a little, just kind of give us the information in brief. You show standby brief. Yep. And here it shows the interface, the group, the priority. P just means it's doing preempt. This is the state is, it's the active router. That's me. Standby is at that address, and this is our virtual IP address. Similar information over here, so except it says I'm the standby, the active's at that IP address, and that's me on the standby. The active is at that IP address. Hope I said that right. I am the standby, and we're using this virtual IP address. Okay. All right, I hope you found this helpful. One of my favorite labs to do. Again, this is something that you can do here as well, just using the switch virtual interfaces instead of physical interfaces that we did here. Like gig 101 on both, you just use the SVIs, and you have to do them for multiple default gateways, VLANs, SVIs. All right. Hope you enjoyed this lab. Thanks for listening, and see you in the next one.